One other way to find out whether a particular quadratic expression is a perfect square or not is through the use of a method called the discriminant method. Do you still remember the formula method of solving quadratic equations, where we have x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a? This is a formula method. For us to have a perfect square, the discriminant b squared minus 4ac must be equal to 0. Or you can write it as b squared must be equal to 4ac. Whichever way, b squared minus 4ac equal to 0 or b squared equal 4ac, any expression that can stand this test is a perfect square. Let us use it and see how it works to know which one is a perfect square and which one is not. I will advise you, if you haven't seen my first video on how to find out which expression is perfect square or not, see that video first before this, so that as we're working with the discriminant method, you can be using the analytical method to check if the discriminant method does it right or not. But I trust and I promise you that the discriminant method is actually the easiest and the best method to use to find out which expression is a perfect square. Let's swing into action immediately. The very first expression we are looking at is expression number A, or expression A, where we have x squared plus 8x plus 16. Using our general quadratic formula, which is ax squared plus bx plus c, you notice that our a in this expression is 1, our b is 8, and our c is 16. So bringing in the discriminant method, which is b squared minus 4ac must equal to 0, or b squared must equal 4ac. Any expression that we try working with this formula and it gives us 0 or b squared equals 4ac, that expression is a perfect square. Let's check this out. B in our example up here is 8, so b squared is 8 squared, minus 4 times our a is 1 times, what's our c? Our c is 16. Let's see, will this give us 0? Let's test it out. 8 squared is 64, minus 4 times 1 is 4, 4 times 16 is 64 also. So this gives us 0. When that is the case, it simply means that the expression is a perfect square. It's as easy as that. It doesn't waste time. So we go to number 2. Number 2, we have y squared minus 6y plus 10. That is actually 6y. I wrote y squared again. It's y squared minus 6y, y squared minus 6y plus 10. We want to check if this is or is not a perfect square. Anyway, ordinarily looking at it, you know it's not a perfect square because this is not a squared term. But let's see. B squared must equal 4ac. What's our b squared here? Our b squared is negative 6 squared. So negative 6 squared must equal 4 times our a is 1. So our c is 10. Negative 6 squared will leave us with 36. Is it the same thing as 4 times 10, 40? No. So our b squared is not equal to 4ac. Therefore, the second expression is not a perfect square. Do you see how it works? Let's try out the third expression. The third expression we have on the board is 4a squared minus 6ab plus 4b squared. 4a squared minus 6ab plus 4b squared. From this expression, testing it out with the discriminant method that says b squared minus 4ac must equal 0. Let's see if this is going to work. What's our b squared? Our b squared is negative 6 squared. What's our a? So minus 4 times our a is 4 and our c is 4 also. 4, 4 and 4 obviously will give us 4 times 4, 16 times 4, 64. And negative 6 squared is 36. 36 minus 64 is not equal to 0. So what this implies is that the third expression is not a perfect square. Okay, what about the fourth expression? The fourth expression is 1/4 of a squared, which is 1/4, we can write it like this, of a squared minus 3a plus 9. Let's check if b squared is equal to 4ac in this expression. What's our b squared? That's negative 3 squared. Is it equal to 4 times a is 1/4, yeah? And what's c? C is 9. Let's see if that works. If we break this down by cancelling out, we'll just have 9 on that side. So on our left hand side, negative 3 squared is 9. And on our right hand side, we have just 9. So 9 is equal to 9. It means that 1/4 of a squared minus 3a squared plus 9 is a perfect square. Do you see how we get the answer? It works. So we have 2 more examples to go. The next one we are looking at right now is 9a squared plus 4a plus 12. Is this a perfect square? Let's check it out as well. B squared must equal 4ac. What's our b squared? 4 squared. Is it equal to 4 times 9 times 12? Not, it's not possible. Because our b here, which is 4 squared, gives us 16. But on our right hand side, we have 4 times 9 times 12. 4 times 9 is already 36. So obviously it's not equal. We can easily tell that, and that's gone. Our last example has w squared minus 8w plus 16. What's our b squared? Our b squared is negative 8 squared. Is it equal to 4ac? 4 times a is 4 and our c is 16. Is 8 squared the same thing as 4 times 16? 8 squared is 64. 4 times 16 is also 64. So 64 is equal to 64. What that means is that w squared minus 8w plus 16 is a perfect square. Do you see how easy that is as well? Watch out for the next season of our video, which is how to make an expression a perfect square. See you then.